Hi everyone, welcome back. Welcome to the session. And this is Mahendra Sharma back again with my new session in continuation of our earlier discussion or earlier session. In this, let's go through a quick recap of previous sessions like the number, variable assignment, and the strings manipulation, printing, and printing in the sense like how to print indexing array elements, uh, list nested listing, how to access each element in the list, different type of listing, and and dictionaries, key value pair concept, how the value get paired in dictionaries, boolean comparison operators, collect sets and comparison operators, logical operators, and FNLs, for loops, while loops, range, and list, comprehensive list. And what's the difference between normal list and the comprehensive list? Like how do we populate the list? That's also one of thing which we have discussed. And today, in today's class, we're gonna discuss. I think the functions also, partially we discussed in our earlier class, and again, we will be discussing about the functions in deeper, like why exactly we use what are the uses of using the functions, and how does it help in effective coding, right? So this is where we gonna discuss. Then after that, we'll be discussing today lambda expressions, map and filter. These are things again we're gonna discuss today. Okay, so when we talk about these are the few examples let me explain you why we use functions. Like if you have done the programming, then you must be knowing why uh, for simple for putting the simple problem across, it takes a lot of lines of code, or sometimes few lines of code for the same purpose need to get repeated number of times, right? And uh, suppose you have to a very small example, very short example. Suppose you have to perform add operation, add or subtraction, any numerical operation if you have to perform, and every time if you are and multiple places in your entire code. Suppose you have 100 lines of code. Out of that, some calculations, some adding operations uh, need to be performed across multiple places. Then what you will do? Again, you will be writing that entire code again and again. And, so for example, let me show you how. For example, I have one program like this. Enter number, very small example, number A. Enter number B. Addition. Again, some print result. Again, enter number A. Enter number. Likewise, suppose the same statement is getting repeated multiple times, then every time these three statements need to get repeated, right? So rather, suppose you have in the same way, you have 100 lines of code where every time these three statements are getting repeated, then in that case, what you're going to do? Like, you're not going to write all these three statements every across 100 lines of code number of times. You're not going to write, right? So if you write that the redundancy in your code, and some it won't be a good practice, because if you are repeating the same code again and again. So in order to avoid that, what we have something called function, right? So what actually the function does, like, it will be keeping all your repeated functions or repeated activities, you can just keep inside one function. Suppose I have created one function here. Example, define function underscore a and a comma b. I have defined, and suppose for example I have just kept it here. So, and for calling this out, print my function underscore a. So this is how the number of times you, and every time, so the number of times you want to call this function, rather writing all this statement, I'm directly calling just this line, right? So in one line you have called the entire statements, the statement which has been coded inside the function, everything you have called out in under one statement. So like it has summarized, it has encapsulated, or it has reduced the number of lines, unnecessary number of lines which has to be repeated. It has just reduced that, right? So that is how, that's the main objective here for writing the function. So here just a small example. So in when we write the code which is which goes on hundreds or thousands of lines of code, there, if we keep repeating, there are certain areas where every time you have to repeat few things, and right, few redundant steps are there. So in order to avoid that, every other functions are the more efficient way which is being called out in order to avoid. The code should be precise and concise and effective and under the best practices. So that's the best approach for for applying the apply I mean for doing the coding, right? So always use the functions whenever you feel like this particular function can be used multiple places across in order to avoid the number of lines of code, and that should be neat and clean, right? So if you have to debug the code, you can directly uh, your code would be precise, so you can debug it better, right? So that is how it works. Now again today we're going to discuss okay, one more thing. See, if the variable what you have defined, again 2 3 key pointers, like if in your program the variable what you have defined at the time of defining the function, if you do not use those functions at the time of calling, then it will not be called out and it may throw error. So just make sure, if you haven't and the variable what you have defined at the time of defining the variable, you must use that variables only. And other than that, while calling out, and sometimes if we do not write the variable, we put the static value or hard-coded value directly while defining out the function. So you can just pass the same value, or you can just while runtime, or while calling out the function, you can input other values as well. But just make sure the number of values what you have defined while defining the function, the number of values only can be passed while calling out the function. So that's the basic expectations from the function standpoint, right? That is how the function works here. So here the array is there because in the my function this new variable has been introduced, so it won't recognize that, right? Because how would it recognize? Because it hasn't found that it hasn't found this variable in the define section. So if it hasn't found, then in that case it will throw an error. Now we go for the lambda expressions. That's also in the modern techniques, we can say, uh, in modern coding, we use that lambda expression, and also in order to concisely writing the code, we use the lambda expressions. The key differentiator for the lambda expressions are, like in the lambda expressions, we do not write the function name, and we do not return any value in the lambda expressions. That's the only difference in while writing out the lambda expressions. Like in order to write the code concised, and that's the main objective across all the coding, in all the coding patterns, in all the coding practices, our objective is to reduce the code, so that while debugging the code, we should not have any challenges in order to debug, and it should be neat and clean. So that's the same thing is get aligned here. Like, in the lambda expressions, we do not specify we do not specify the function name and the return value. So here, for example, this is one function defined times 2 var return. So we are defining a function called times 2, and in that we have passed one variable, and at the time of returning, we are returning var multiplied by 2. So if we have passed this 3 while calling out the function, we have called out this function times 2 var, uh, and instead of var, we have passed the value 3. And while returning, it is going to return the value which is 6, means the value we have passed 3, and it is going to be multiplied by 2, and the 6 has been passed here, right? If the same thing we write in lambda expressions, then we do not need to write any function name here. We directly write like this, where the variable what you have passed here, where and multiplied by 2, right? So in the same where colon where multiplied by 2, so it will return, and that lambda expressions you have to write. Okay, so once we write here, again the same value would be, same result will be returned, right? So that's the difference only in the lambda expressions. Is there any questions around? No, we'll see more examples down the line in some other use cases, like how to use lambda expressions effectively. This is, other than the heads up, this is just the understanding what is the objective of using the lambda expressions, how to use that in the syntax wise, and what is the core objective of using that, right? So that's the lambda expression. Now we go for map and filter. This is another key important aspect of this Python. Suppose I do have one list. This is list, right? In this list we have defined these values, and there is another variable in which we have specified empty list, right? So if I write the for loop here for item in sequence, meaning it is this item variable is going to access each element in your sequence, and the sequence is 5 4 3 2 1, right? So the first 5 4 3 2 1 and so on, it is going to access each item or each element. So, and here we have one empty list. So how are we going to populate the new list, meaning k? So item k dot append times 2 item. So times 2 is the function. K dot append times 2 is the function. What is the function name? Times 2 and item. Item is what? Like each element, like in the first time item, it is going to access a 5. So once we call the times 2 function, it will return where value. Where value is what? Item. Item value is what? 5. 5 is going to be multiplied by 2, and it is going to be returned 2 once we try printing that k value, right? So these values are being extended after calling this lambda expression or function, you can say. This is the function you have called out here. So if you call out this function here, it will multiply each value one after another, and because while reading out each value in the list, and so that is how the k value would be populated, as it k is also one of the lists. So your all the sequence will be repopulated here in the form of listing for k. When we try printing k, it is not going to print the individual value, right? It is printing, it is going to print the entire listing, right? So that is how it has printed the entire listing and uh, append it to the, the function, right? So this is just one example. Let's go further another example. This is another example. Define times 2 where and where into the same function we are called out, and k is the, the empty list for item in the sequence, append 2 times print k, the same thing. And here in the map, how do we write that? List map, pass the function and the arguments. In the map, how does it work? Map also, it is going to map the same value, right? Say method 2, the same thing is going to be repeated. If you write, we have defined the function here, defined, this is the function, right? This is the function and this is the list. So performing the same operation via method 1, we have repeated the same thing, like how we can print the, this is the function we have used in the previous previous example. So here either we can use this one, and another way, very short in just one line, how can we write that? List as list, we are accessing the list and we can map by calling out the function in this sequence, right? We because we are accessing all the elements in the listing type of sequence, so we'll write list and map. Map is what? It is going to map each element in your listing and what function we are going to map with your list dataset. So we write map here, and the map is going to list. Under the list, map is going to perform the mapping for each element in your list using times 2 function, and the times 2 function is going to return the same value. So in just one liner, how can you write that? That is how it has been defined here, right? Pass the function and the argument. Pass the function and the argument. Function is times 2. Function is times 2. Times 2 is the function, right? We are passing an argument. And sequence, and this is the sequence, is the data set, list data set, in which this times 2 function is going to be executed, right? So that is how it is going to work. So you just make sure whenever, if you want to write the same steps, if you want to write this, if you want to write the same code in very precisely in one liner, and how to use the map, in that, the function and the argument can be passed parallel with the map parameter, right? So another example, method 3. In that, what happens? Like in that, you have one list data set, and in that k equal to list map lambda. Here we have used the lambda expression. Explicitly we specify for the lambda expression, we explicitly specify lambda keyword, right? So we have used the map and lambda keyword instead of calling out the function. We have specifically mentioned lambda, and we are calling out the function where equal to where colon where into multiplied by 2, and where in the sequence is the argument or the list, and print k. So again, it is going to give the same result, isn't it? So we got the same result here. And how we did that? Via lambda expression. In lambda expression, we haven't defined the entire function or anything. We are simply called out with the map function. It is going to map your the argument and the function. Instead of function, we have specified lambda expression, and lambda expression is going to work with your argument. Argument is the sequence list data set, right? So we got the same results. So hope you got the understanding of lambda expression, and if you have any doubt, you can just put, or doubt any question, you can your queries, you can just put down your questions in the comment section. Even if you can, still if you want to connect me with for any for any detailed discussion or something, that you can drop it an email and I will revert on, and even we can connect. And if you haven't subscribed my channel, kindly subscribe and and share the video across. Okay, thank you. Please like my video and subscribe my channel, Python Guru. Thank you.